Half of all residential buildings in the United States show visible mold or detectable mold odor. That is according to the National Institute for Occupational Safety and Health. The number one killer of residential structures is not fire, not wind, and not earthquakes. It is moisture. And the modern building industry's answer to moisture is a plastic sheet stapled to the inside of your wall. A vapor barrier that traps water inside the very structure it is supposed to protect. Meanwhile, in Norway, wooden stave churches built over 800 years ago are still standing. No plastic, no vapor barriers, no HVAC systems running around the clock. 7 construction techniques that Scandinavian builders used every single day have been completely written out of the modern building code. Techniques that kept structures dry, warm, and standing for centuries in some of the harshest weather on Earth. By the end of this video, you will understand why your house is rotting from the inside out while theirs never did. Number 1. Self-tightening corner joints. Walk into any modern construction site and you will see 2x4s nailed together, then corked, then wrapped in house wrap, then sealed with expanding foam. Every single one of those seals will degrade. Cork cracks within 5 to 10 years. Foam shrinks. House wrap tears. Your wall assembly starts leaking from the day it is finished. Scandinavian builders solved this problem over 800 years ago with a technique called lafting. They carved interlocking corner notches into solid logs. Saddle-shaped joints where the curve of one log sat precisely inside the curve of the log below it. No nails, no cork, no adhesive of any kind. And here is the part that makes modern engineers uncomfortable. As the wood dried and shrank over the first few years, the joints pulled themselves tighter. The notch had a pronounced wedge on the interior face. When the log above it shrank, it compressed downward into that wedge. Gravity and the natural behavior of the wood did the sealing work. The result was an airtight corner that improved with age instead of degrading. A full-scribe Scandinavian log joint from the 12th century is tighter today than it was the year it was built. Your cork gun cannot compete with that. The technique had regional variations. Norwegian builders favoured the saddle notch, a rounded profile that matched the natural curvature of the log. Swedish builders used dovetail notches with crisp angles that offered even greater resistance to lateral movement. Finnish corner joints used rounder profiles suited to the dense northern timber of the region. All of them shared the same core principle: gravity and shrinkage do the work, not sealant. For your next building project, look into full-scribe log construction. Builders in Canada and the northern United States still use the compression-fit saddle notch derived from the original Scandinavian technique. A Canadian log builder named Del Radomski reinvented and popularized the shrink-to-fit method in the modern era. It costs more up front. It never needs resealing. Number 2. Living roofs. Your asphalt shingle roof has a lifespan of about 20 to 30 years. After that, you tear it off, send it to a landfill, and spend $10,000 to $15,000 putting on a new one. Scandinavian builders used a roofing system that has been documented since at least 300 AD, and until the late 19th century, it was the most common roof on rural log houses across Norway, Sweden, and Finland. The system worked in layers. First, wooden roof boards laid across the rafters. On top of that, up to 16 layers of birch bark, stripped from trees in spring while the sap was running. Birch bark contains a natural compound called betulin that repels water and resists decay. It is nature's waterproof membrane, no factory required. On top of the bark, they laid sod. Living grass and soil, typically 4 to 6 inches, 10 to 15 centimeters thick. The sod was not decoration, it was a thermal regulator. In winter, the soil and grass trapped heat inside the structure. In summer, the evaporation from the living plants cooled the roof surface. The weight of the sod also compressed the birch bark layers tighter over time, improving the waterproof seal. A well-built sod roof lasted about 30 years before needing replacement, comparable to modern asphalt shingles, but using materials that cost nothing and came from the land surrounding the house. Research from the National Research Council Canada confirmed that green roofs reduce heat flow through roofing systems through 4 mechanisms: shading, insulation, evapotranspiration, and increased thermal mass. A separate study from Luleå University of Technology in Sweden examined an extensive green roof on a building in the subarctic town of Kiruna and found measurable thermal benefits from the soil and vegetation layer. The Scandinavians figured this out over 1,500 years before either study was published. For your home, modern green roof systems exist and are gaining traction, but in Scandinavia, this was never a luxury add-on for architect magazines. It was standard construction for every farmhouse, storehouse, and church in the country. Number 3. Pine tar preservation. Here is what nobody tells you about modern pressure-treated lumber. The chemicals that protect it, alkaline copper quaternary or ACQ, are corrosive to metal fasteners. Your deck screws, your joist hangers, your nails. They corrode faster in direct contact with pressure-treated wood. You are using a preservative that attacks the hardware, holding your structure together. Scandinavian builders preserved wood with pine tar. Research published through Cambridge University documents Viking Age tar production at an industrial scale as early as the 8th century AD. Calibrated radiocarbon dates from tar production sites in Scandinavia give a range of 680 to 900 AD for the oldest known features. Builders stacked split pine roots in a covered pit or clay kiln, excluded the air, and heated them slowly. The resin melted and dripped into a container below. They brushed this tar onto every exposed surface of their buildings and ships. Pine tar does 3 things that modern chemical treatments do not. It penetrates deep into the wood grain instead of just coating the surface. It is naturally antifungal and antimicrobial, and it remains flexible, expanding and contracting with the wood through seasonal changes instead of cracking and peeling. Norway's 28 surviving stave churches have been maintained with pine tar for centuries. The Borgund stave church, built around 1180 AD, still has original structural timber that has never rotted. That is over 840 years of exposure to Norwegian rain, snow, and temperatures well below zero, protected by tree resin, cooked in a pit. You can still buy authentic Scandinavian pine tar. A gallon costs roughly $40 and covers 100 to 150 square feet, 9 to 14 square meters on raw wood. No toxic off-gassing, no corroded hardware, no expiration date. Number 4. Thermal mass walls. This is the one that changes how you think about heating entirely. Heating and cooling account for nearly 50% of your home's total energy bill. The average American household spends over $1,300 a year just fighting temperature. Your modern stick-framed wall is a 2x4 or 2x6 cavity filled with fiberglass insulation and sealed behind drywall. It resists heat transfer. That is what insulation does. It slows the movement of heat from one side to the other. But Scandinavian log walls did something insulation cannot do. They stored heat. A solid log wall built from timber 10 to 12 inches, 25 to 30 centimeters, thick acts as a thermal flywheel. During the day or while a fire burns, the wood absorbs heat deep into its mass. When the fire goes out or the temperature drops, the wall slowly releases that stored energy back into the room. Studies on log cabin thermal performance have shown that a solid log structure can hold livable temperatures for days after the heat source is removed. In one comparison, a log cabin maintained 54 degrees Fahrenheit, 12 degrees Celsius, after 48 hours without heat, while a modern prefabricated house with an R value of 25 and triple glazed windows dropped to 36 degrees Fahrenheit, 2 degrees Celsius, in just 9 hours. Your insulated wall reacts to temperature changes. A Scandinavian log wall absorbs them. One needs constant energy input, the other stores it and gives it back. And here is the practical reality. A 50-year-old log home is often more thermally efficient than a brand new one because the wood has fully settled, the joints have fully compressed, and the thermal mass has only improved. It is an asset that appreciates in function. Modern stick-framed houses depreciate from the moment they are finished. Number 5. The Kakelugn. In the 18th century, Sweden was running out of firewood. Conventional iron stoves burned through fuel at a staggering rate, and the country's forests were being stripped bare. A Swedish architect named Carl Johan Cronstedt, working with General Fabian Reder, redesigned the traditional tile stove into something that changed Scandinavian heating forever. He called it the Kakelugn, literally tile stove in Swedish. The design burned wood at extremely high temperatures, typically between 1,500 and 1,900 degrees Fahrenheit, 850 to 1,050 degrees Celsius. A standard iron stove burns at around 850 to 1,100 degrees Fahrenheit, 450 to 600 degrees Celsius. The hotter burn meant more complete combustion and far less wasted fuel, but the genius was in the exhaust path. Instead of sending hot gases straight up the chimney, the design redirected them through a series of flue channels built into the masonry body of the stove. The bricks absorbed the heat. Then for the next 18 to 24 hours, those bricks radiated warmth into the room slowly and evenly, without a single additional piece of fuel. Independent testing showed the Kakelugn was 8 times more efficient than a conventional wood stove. One fire, 2.5 hours of burning, a full day of heat, and it did not heat the air the way a forced air system does. It heated the surfaces, your walls, your floor, your furniture. Radiant heat warms objects directly, which means the room feels comfortable at a lower air temperature. You use less energy to feel warmer. The average American spends over $1,300 a year running a forced air system that pushes heated air through ducts, losing energy at every joint and bend. Cronstedt solved this problem 250 years ago with bricks and a fire. Number 6. Elevated foundations. Your modern house sits on a concrete slab or a poured foundation that makes direct contact with the ground. Moisture wicks up through that concrete. Ground vapor pushes against it from below. That is why your basement smells the way it does. And that is why foundation moisture is the single largest driver of mold in residential construction. In Norway, traditional storehouses called stabber were built on elevated wooden posts or stone stilts. The word itself comes from stavbur, literally pillar building. The building was raised completely above the ground, creating an open air gap beneath the floor that allowed constant air circulation. This technique is documented as far back as the 900s in the gulleting law, one of the oldest known legal codes in Scandinavia. The elevation did 3 things at once. It prevented ground moisture from ever reaching the wooden structure. The constant airflow beneath the floor kept the underside of the building dry, eliminating the conditions where rot and mold begin. And the gap made it physically impossible for rodents to reach the stored food inside. The wooden steps were freestanding. They did not touch the building itself, so nothing could climb from ground level directly into the structure. For your own property, this principle still applies. If you are building an outbuilding, a workshop, or a storage shed, consider elevating it on pier foundations with an open-air gap beneath the floor. The ventilation alone will extend the life of your structure by decades. Modern post and pier foundations are the direct descendant of the stave principle. Modern building science has only recently caught up to this. Ventilated crawl spaces are now recognized as superior to sealed slabs for moisture management in many climate zones. The Scandinavians made it standard practice over 1,000 years ago, and they did it without a single building inspector telling them to. Number 7. Breathable walls. This last one is not just another technique, it is the principle that made every other technique work, and it is the one that modern building codes have most aggressively eliminated. Your modern wall has a vapor barrier, a sheet of polyethylene plastic stapled to the interior side of the wall cavity. Its job is to stop moisture from your indoor air from entering the insulation. In theory, this protects the wall from getting wet. In practice, it creates a trap. When moisture enters the wall from the outside, through a failed seal, through a crack, through condensation, it cannot dry inward because the plastic blocks it. The moisture sits inside your wall. It soaks into the framing. Mold grows. Rot begins. You do not see it until the damage costs thousands of dollars. Researchers in Denmark found that traditional vapor barriers did not significantly reduce the overall moisture content of wall assemblies. Vapor diffusion turned out to be the smallest of 4 moisture transfer mechanisms studied. The barrier was solving the wrong problem. Scandinavian log walls were breathable by design. Solid wood allows moisture vapor to pass through it slowly, a property called vapor permeability. When the interior is more humid than the exterior, moisture migrates outward through the logs. When conditions reverse, the flow reverses. The wall self-regulates based on the conditions around it, adjusting passively to seasonal changes in humidity and temperature. No plastic, no trapped moisture, no hidden mold, no mechanical dehumidifier running in your crawl space. Here is what should make you angry. The modern building code requires a vapor barrier in most climate zones. It mandates a component that traps moisture inside a structure built from materials that rot when wet. Scandinavian builders spent 1,000 years perfecting walls that never trapped moisture at all. The same wood that stored heat, the same joints that tightened with age, the same tar that repelled water. They all worked because the entire wall system could breathe. Every one of these 7 techniques worked as part of a complete system. The thermal mass stored heat. The Kakelugn generated it efficiently. The living roof insulated from above. The elevated foundation eliminated moisture from below. The pine tar protected the wood. The corner joints sealed tighter with age. And the breathable walls made sure no moisture was ever trapped inside the structure. Remove one element, and the system still works. Remove all of them, which is exactly what modern construction has done, and you get a house that fights physics instead of working with it. The medieval Scandinavian builder, with a broadaxe and a bucket of pine tar, was not primitive. He was solving problems that your general contractor is still creating. We traded 1,000 years of proven engineering for speed, cheap materials, and plastic sheets. The knowledge is still there. The choice is yours.